Hello everybody. Today we are going to highlight one of the features of Astro-COLIBRI, and that is the visibility tools. You have certainly seen these in the lower right corner of the front end, and we are going to show you what these means and what they can be used for. But let's first start with a quick introduction about visibility of an astrophysical source in an observatory. How do we define visibility? What parameters are useful? And then we come to the implementation and the use of these visibility estimates in Astro-COLIBRI. The main parameters driving the visibility of an astrophysical source on a given location on the Earth are the zenith angle, where the definition is that 0° means pointing vertically up. And this, of course, is equal to an altitude above the horizon of 90 degrees. So zenith angle and altitude are interchangeable just by doing 90 degrees minus the other. The other parameters defining the observability of a source is the twilight level and the moonlight level. Both of them are influencing mainly the quality of your data. Starting with the zenith angle, which is the main criteria for defining the visibility of an astrophysical source. And this is mainly driven by the atmospheric absorption. So the light from your source has to go through the atmosphere to reach your telescope. And if the source is vertically above the ground, you only have to go through one layer of atmosphere. If you have to do inclined observations at a higher zenith angle, the atmospheric absorption gets greater. And this causes a loss of resolution, sensitivity, or for the high energy observatories in the energy threshold of your observations. So the best conditions are always at low zenith angles. So these are the favored ones. This means high altitudes. We want to pick time ranges where these conditions are fulfilled. The next main factor is the amount of sunlight that remains at dusk and dawn. And this is driven by the angle at which the sun is below the horizon. This angle defines various levels of twilight. We call it civil, nautical, and astronomical twilight. The bulk of the astrophysical observations are done after the astronomical twilight. Some of the observatories also do observing during astronomical twilight already. But this has to be taken into account in your visibility calculation. And the last point we want to discuss here is moonlight. So most of the observatories are influenced by the scattered light of the moon and can only operate at low moon phases or when the moon is below the horizon. Other more complex calculations can take into account the distance of the source you want to observe to the moon, and maybe also complete simulations of the expected background light due to scattered moonlight. And I will now go to the Astro-COLIBRI website to illustrate you how these different parameters influencing the visibility of an astrophysical source is taken into account in our tool. So you see here the Astro-COLIBRI front end in the web page. You can select your favorite source either on the sky view or the card view, or do a dedicated cone search for your favorite location. That's what I've done here. I've picked a location and then I want to assess the visibility. So I click on these plots given here and I will run you through the details that they illustrate. All of the visibility plots are always given in UTC, but their content is driven by the location of the observatory. Here we have chosen the observatory Hess, which is located in Namibia. Therefore, we get the definition of the nighttime, which is given here in dark, and the various twilight levels, which are indicated by these gray shaded areas at a given time in the day. If you have an observatory in Australia or in Chile, of course, already this black nighttime period will shift to the appropriate location. And then you see your source. This is this colorful plot here, rising in the sky over time, reaching higher and higher altitudes. The color coding of these points is the azimuth, and of course the altitude, or in other words, the zenith angle, is given on the Y scale. And then typical limits for observations are 30 degrees and 45 degrees altitude. So these are indicated here for easier readability by these red dashed lines. And when the source is above these indicative lines, you have the solid red lines, and start and stop of the observation is then indicated by these red markers. The points of these markers are also given in the legend below, so you can read off directly when the source would be above a certain altitude range or below a zenith angle range, and you could use this directly to schedule observations. The other visibility plot that we provide is from an API of one of the partner institutes, the Max Planck Institute in Heidelberg, and there you give a more long-term view. Again, the same x-axis where you see the time over the day in UTC, but then the y-axis is now the next month of observation, and the color coding is the visibility of the source at the given day in the upcoming period. So the lighter the color blue is, the higher the source is in the sky. So you get again the information on the zenith angle. And this yellow box is where the source is blocked by moonlight. So you cannot observe at the given observatory under these conditions. You also get a link to the website provided by this external API where you see the same plot. And further down, you also get the detailed information on the exact time windows a source is observable under a given altitude or zenith limit. So you can select your day and then read off directly during which time period the source would be observable and use that for scheduling your observation. Coming to a few corner cases, one of them is when parts of your observing window is influenced by moonlight, but the moonlight is not so strong that it would prevent you observing altogether. So we indicated here by this dedicated color. And you see that for this example, which is the same source as before, but in a few days' time, the first half of the night would be influenced by moon because the moon is above the horizon, but the moonlight is not so strong that you wouldn't be able to observe. So you get these indications by the time periods given in brackets. So these are time periods where the moon influences your observations, but doesn't prevent it. The situation changes further a couple of days later, when then the moonlight is too strong for conducting reasonable observations, and therefore the whole period is given in a brownish color, and then the given time window where you can observe is limited by the end of this moonlight period. I hope you got a better idea on what the visibility plots in Astro-COLIBRI are. Please feel free to provide comments and see you next time. Bye.